Welcome. Thank you for coming. Hope you had a great launch and that you're having a great conference so far. This session, it's going to be the power of Kafka in the Oracle Cloud, and we're going to take a deep dive into Event Hub Cloud Service, which is actually managed Kafka in the Oracle Cloud. So I will just briefly introduce myself. My name is Arturo Viveros. I come from Mexico, but I actually work and live in Norway. And yeah, it's my first time in India, actually, so I'm very happy to be presenting here. I also presented in Hyderabad a week ago, so it has been nice. And yeah, there are a couple of links, my Twitter. If you want to follow me, I usually tweet about this stuff. I've written a couple of things as well. This about the company for which I work, which is important for me to mention because they also support me in this travel and this activities. The name is Cisco. It's a Norwegian company, consulting company. We are basically focused on integration and all kinds of integration, data integration, service integration, enterprise architecture. We have a multinational team. I actually have a lot of colleagues from India as well. So yeah, that's Cisco. And just quickly, the commercial about the Oracle ACE program. This is a very nice program where many people have gotten involved to support and help grow this community. Oracle experts, basically, or Java experts. We have some ACEs and developer champions and ACE directors presenting here at Bangalore. And yeah, if you can, if you spot them around, just talk to them, ask them a lot of questions. If you want to become an ACE or nominate an ACE, do so. Lori Loruso, which is one of the members of this committee, is here in the conference. So if you are interested in becoming part of the program, just look for her and ask her what are the requisites to become an ACE. Okay, so yeah, that's the ACE program, and this is our agenda. Okay, I'm gonna give a very brief introduction to Kafka, just some details, because if I start talking about just Kafka, we could be here like all day. It's a very big topic. Then I will try to provide some justification and some examples about why do we want Kafka in the cloud, or what is the fit? You know, because we will be talking about Event Hub Cloud Service. You know, so why would we use a service like this for building cloud applications or cloud architectures? Then we will go into the product, and we will see an overview and a little bit of a deep dive into Event Hub Cloud Service. Let's see how much time we got to see all of the features. And in the end, I will mention some interesting use cases, some architectural considerations for the use of this product. And then let's see if we have also some 5 minutes or something for questions and answers. But even if we run out of time, you can find me around and ask me whatever you want about this session. So yeah, let's begin. Okay. So what is Kafka? Does any of you have heard about Kafka or are working with Kafka? How many people here are familiar with the concept of Kafka? At least heard it like buzzword or heard it around. Yeah. So okay, Apache Kafka. It is a distributed streaming platform. Okay. It handles data streams. I will tell you more about why it's a distributed streaming platform. It fits certain types of architectures and certain needs of applications nowadays. It's not for like everything. It's not a substitute for the database, you know. But it's a very powerful tool, and we will see why. It has many capabilities, but among the most important ones are this: it can publish and subscribe to streams of records, big streams of data, you know, in a similar fashion to what message queuing does, or traditional enterprise messaging systems, you know, like traditional JMS or something like that. But it's much more powerful and in a larger scale. You know, Kafka is for handling very large amounts of data, even big data scenarios. It stores these streams as well in a fault-tolerant and durable way, specifically durable. Maybe some of you have heard this this term about immutability, that the Kafka log is immutable. It cannot be deleted or can hardly be deleted. It doesn't change. It records everything that has been happening and that will happen and that will keep happening in a very smart and manageable way. And it lets us process these streams of records as they are happening. So this is one of the most important features about Kafka, that together with some other components that I will also show you, it lets us handle these huge amounts of data in real time. You know, we have like the warm, hot data as it happens. You know, it's not. It's a change of paradigm as opposed to going and pulling everything from a database, for example. You know, and then you have like cold data, a little bit outdated, even if it's minutes or seconds, but it's not what's happening in the moment. So Kafka lets you know what's happening in the moment with your systems, with your customers, with your applications, with all your data. Okay? Basically, this is what I just said. You know, it has processing capabilities. Many of those and many other components have built on top of this. You know, like there's KSQL, there's Kafka Streams, there's Akka Streams. It provides the messaging and integration capabilities. You know, so it has APIs to produce towards Kafka, consume from Kafka, connect to Kafka from different providers, and it can work as it works also as a data store. You know, so we have topics, partitions, replicas, materialized views, and some other things, compaction, retention, which we can configure because our Kafka, our event log, it's also a data store, and it keeps the information there. You know, I borrowed some couple of slides from my colleague Jorge, which works also in Cisco. You will hardly find the biggest Kafka expert in the world, I think. So if you're interested in this topic, make sure to follow that guide. He's really good and he's even a contributor to the Kafka project itself. So that's why I borrowed a couple of slides from him. He's a very good friend of mine. Some Kafka facts, just to get context. You know, this product, this tool was developed by LinkedIn. You know, I guess everybody has heard about LinkedIn about, I don't know, like 7 years ago, 8 years ago. But it quickly grew on its potential, and it was open sourced in 2011 by Apache Incubator. Okay, it graduated as an Apache project very quickly, 2012. Then a company named Confluent was created in 2014, and Confluent builds on top of Kafka, and Confluent has created a lot of tools to connect, to work, to process with Kafka. My company, Cisco, is also partnered with Confluent. You can see the number of messages processed each day by LinkedIn, for example. Okay? And over 35 of the biggest companies in the world are already using Kafka for one thing or another, for some scenarios, some bigger, some smaller, but many important companies that handle big amounts of data are using Kafka in production with success. So that's Kafka. You know, some of these companies are very famous. You know, like Netflix is one of the most famous just cases. Airbnb, for example, Pinterest, PayPal. And just by looking at these companies, you can see or you can imagine the volume of data they usually handle. Like eBay, for example, it handles tons of data, tons of events, and we're going to talk a little bit more about events, and I'm going to give you some examples of my own experience. But yeah, these are good examples of the companies that use Kafka worldwide. This is how a typical Kafka cluster looks like. We're not going very deep into this because it would take us the whole session to explain, but yeah, Kafka, we said that it's a distributed streaming platform. You know? So being distributed, it normally is deployed on a cluster, you know, distributed way. Okay? It uses this component, typically named Zookeeper, to manage the cluster. So it's a component that usually comes together with Kafka. There are producers, which are putting messages in there. There are consumers, which are reading from the streams. You know? And inside we have topics, we have partitions. Basically, those are like the two more basic concepts of a Kafka architecture. Okay? If you're familiar with JMS, for example, this will ring a bell like topic, you know, JMS topic or JMS queue. Here we have topics as well. Okay? And yeah, that's the basic architecture. Just keep it in mind. Okay? And why do we want to have Kafka in the cloud? Okay, and basically there could be many reasons, and with Kafka we could go like in many different ways. But in this session, we are talking about Event Hub Cloud Service, which is, I think, a good name for the product because it's focused on supporting event-driven architecture. Okay? Event-driven architecture, which is a fairly new design paradigm in which our software executes in response or reacts in response of the events it is receiving or the events that are happening, all over the place. So this event-driven architecture, what it does, it lets our applications, our systems resemble a little bit more or get closer to what the end user wants. It resembles like real life, You're getting information in real time. You're processing what's happening in the moment. Okay. Why should we care? Why does that matter? Okay, because events drive a lot of things, or they have a lot of potential. They let us move faster. They foster loose coupling, scalability, and here, maybe good analogy. I consider, for example, the way we work as human beings, or our perception. We are usually receiving stimuli, and we are registering events from everywhere in real time, and we react in real time to these events. So for example, yesterday I was thinking, okay, for example, to cross a street here in Bangalore, it's quite a challenge, with all the traffic and the tuk-tuks and everything. But you are receiving and processing all of this information. There's a truck, there's a tuk-tuk, there's a bicycle, there's a motorcycle, and I need to be quick and run and pick the right moment. But if I wasn't being able to process this information in real time with my brain, then it would be impossible to cross the street. If I was getting if my brain had like a 3-second delay or 5-second delay, and I tried to cross the street, I would certainly be run over by a bus or something. So that's the importance of real-time information, real-time events. If I didn't have that possibility, I would have to find a workaround, like building a bridge on top of the street or a tunnel or someplace I could go easily without worrying of whatever is happening out there. But that's costly, and that takes time, and it's not the ideal situation. So that's why we want to handle events appropriately. We say that events allow for time travel also, which is I want to recall events that already happened, and I want to do it quickly, and I want to have the complete information. So data streams let us do this. Okay, it's not the same as going into the database and trying to get scattered information out of there. It's the same important information. If someone comes and asks me, what is your name? I have it here, right? Arturo. I wouldn't say like, oh, I don't know, let me go into my birth certificate and then I can tell you my name or my birth date, So that's like, it's a very simple example, but that's real-time, event-driven, as opposed to traditional integration, traditional data integration. So that's why we want to handle events. Another consideration, stream processing, which we're talking about, versus traditional integration, traditional ETL. When we are talking about huge amounts of data here. So what do we traditionally do when we want to move huge amounts of data from one system to another or from one database to another? We do ETL a lot, like batch processing. That's very scalable. That lets us move millions, billions of records with good performance and everything, but it's not real time. We get the information the next day or in a few hours, so it's like cold information. We have the traditional enterprise integration like web services and SOA and service buses, which let us do some real-time stuff, but they are not very scalable. If I have worked, for example, in companies that try to move big amounts of data through a service bus, for example, Oracle service bus, and that's not a very good idea. It doesn't scale so well. When you're talking about these big amounts of information, and I can think of an example. In Mexico, when I was working back in Mexico, I used to work for my customer was a pawn shop where you go and pawn your stuff and they give you money. But it's very big in Mexico, so they have stores all over the country, and events are happening all the time. So they wanted to use these events for many things and feed many systems with them. and they were using like traditional enterprise architecture with service bus and all of this stuff. And what happens? We have too many messages coming in. Maybe the boss can take them because it's using a lot of processing power. Then it just spits this information out to the many systems, but the systems cannot handle correctly all the load, and we will talk a little bit more about this in a few minutes. But then we start losing information. Some systems get the messages, some systems don't get the messages. Then we have inconsistency, and then we have slow performance, And then they decide, okay, let's not do this, let's use ETL, and we will have the information one day after, but at least it will be reliable. But an alternative is streaming platform, Kafka, to handle this kind of situation. Another advantage of using Kafka, an event log, and streaming platform is that it empowers or enables us to implement these very innovative and very impressive design patterns like CQRS, like event sourcing, materialized views, backpressure, and some more. CQRS, for example, lets us decouple completely the reading and writing from databases or systems of records. Backpressure, I think I have yes, this is my example of, just to talk a little bit more about one of these patterns, backpressure, and I have a demo of this. Backpressure is when a system is being overloaded by all the number of messages coming, like in this figure. The producer is very fast, but the consumer is not as fast, so this is producing a lot of messages. That one has a certain capacity, and when it reaches its capacity, maybe it has a buffer or something, but that can also be filled. And then what happens? The messages, we start losing them. They start being dropped. It doesn't have, it cannot put them anywhere. And that's what happens, for example, that image is from Alibaba, I think, when they have too many packages, and what do they do with them? They cannot handle it anymore, and of course, something's going to get lost in there, and some packages are not going to reach their destination, and some customers are going to be very angry because of this mess. So that's backpressure is the pattern we use to handle this, and I will show you when we reach the demo. Okay, but just to finish the introduction in summary, when we want to handle events, big amounts of data, and we do it correctly with event-driven architecture and streaming platforms, it's like this is the difference, like going in circles or going straight up to what we want at like speed of light. So that's what Kafka lets us do. And it's, as I said, it's not for every case, it's not for every scenario, but when we want to handle huge amounts of data and event-driven architecture, then Kafka is a very good option. And Event Hub Cloud Service from Oracle is one product that leverages and implements this kind of technology. So yeah, let's go and take a look at the product. Let's see. Okay, so if we just take a look at the web page for Event Hub Cloud Service, as I said, it's managed Kafka in the cloud. This is platform as a service. So what is we talked about the advantages of using Kafka and streaming platforms, but what is the advantage also of having managed Kafka in the cloud, that we don't, as with any PaaS, that we don't need to worry about infrastructure or configuration or maintenance or patching. Oracle takes care of that. We just create our Kafka cluster, we give the characteristics we want, and Oracle will provision it for us, and they will take care of this service, and we'll keep it running. We can scale up or down if we want. We will be in we can choose different payment models, but then we will have a Kafka implementation available to let our data flow through it. So that's basically the image in the right. And one other advantage within the Oracle Cloud, we could provision this service in the Oracle Cloud and use it with any other cloud providers or connect it to whatever we want. But if we're also working with some additional services within the Oracle Cloud, then there is some out-of-the-box integration with these products. There we can see, like, for example, the Oracle database and IoT, and the application container cloud and the API cloud service. So just with couple of clicks and couple of some configurations, we can interact. You know? So that's the like the value which is being provided by this service. Now let's go into it. Okay. Let me make this smaller. Yes. Okay. So basically, I just provisioned this this instance for the Oracle Code demo. I actually provisioned it like half an hour ago because I was having some trouble and had to recreate it. But this is a dedicated Kafka, managed Kafka instance, okay? It's like the basic configuration. If I go into this summary page, I can see the topology. How is it created? What kind of resources is it using? You know, like for example, it's created in 2 nodes. It's using three CPUs, some memory, some storage. You know, I created some tag to identify it easily. But there is some important information here, and it's this. I think it's one of the services within the Oracle Cloud, which is very easy to get started with. You know, it's very quick to create. You can create it in like 5-10 minutes. In the end, I will provide some a slide with some links to resources where you can have the step-by-step guide on how to provision this service. So those are there. I think you can already download my presentation from the Oracle Code webpage. But for example, if I want just to write some code and start connecting and sending messages to this, well, I need to create a topic, which I will show. But once I created a topic, if I want to start pushing some information or reading some information from it, I just need to use this this connection descriptor. You know, this is the IP address and the port. This here, if you see, Zookeeper is also running to manage the cluster. We talked about that Zookeeper is always part of the Kafka architecture. I configured this to use Kafka Connect, you know, and Kafka Connect is an API on top of Kafka that lets us connect very easily to several sources and several sinks, several destinations, you know. What else can I see? Yeah, that's basically it. From here, I can scale up or down my service. I can stop it if I want, or restart it. I can do health check, okay? Some monitoring, but this is just my Kafka backbone, so to speak, okay? This is the Kafka cluster that has been provisioned for me. In able to start using it or to start pushing or pulling some information from it, I need to create topics, partitions, you know, like the logical segments that are going to be handling this information. So I can come here. These are my topics. I created 2 of them, demo topic and demo topic 2. They are created on top of different managed Kafka instances. You know, this is in the dedicated Kafka service. This is like in the generic one. That's why it has this little icon here. Okay. Creating the topic, it takes like 1 minute. I will create one right now. Let's see if the Wi-Fi helps us. Instance name, for example, I'm going to give a name to this topic. So I can say like demo topic 3. Okay. Description, it's just a demo. Okay. I provide an email where I can get notifications about this topic. So when this topic is created or if it's down or something, I will get notification in this email address. It will be hosted on my dedicated instance, which is Oracle Code Demo. I can tag it, you know, Oracle Code. If I have a lot of stuff going on in my cloud account, then these tags will be useful to find my components. Okay. 2 partitions, that's the default, it's okay. Retention period, 24 hours. Log cleanup policy, delete, that's okay. So that's all I need, okay? Confirm and create, okay? And it will start, the Oracle Cloud will start working automatically to create this topic. And in a couple of minutes, it should be ready. I think it's ready now. Yeah, it was very fast, actually. So if I look at this topic, I can see the information. You know, there are several ways in which I can connect to this topic to produce or to consume. You know, I can use, as we saw in the. Let me show you one more slide, or go back to one of the slides. As we saw here, we have several different capabilities, you know. So for example, to do messaging and integration, I have direct APIs which I can use to produce and connect, for example, from some Java code. But I also have on top stream capabilities. I have KSQL. I have another stateless API, stateful API. So I can use, if I'm using, for example, Akka Streams or Kafka Streams or the Confluent platform, or some other Oracle service or some other technology, there are also different APIs that I can use to connect to this topic. I can use just plain Java code and exploit these APIs, which I will show you. Okay. I have another slide that I think it's better at the end. Yeah, this is normally the way we can do it. You know, if we see we have Kafka in the middle, okay, and we have the messaging API, we have the connect API, we have the streams API, so we can have apps there, apps here, data sources or data destinations there, sinks, okay? And we can use all of these APIs to interact with Kafka. You know that the choice is ours. The different APIs have different capabilities and different strengths. You know, so it depends on what we want to do. Particularly, we at Cisco, we are using a lot of. We are partners of Confluent, so we use Confluent platform. We use Kafka Connect, and we use also Kafka Streams and Akka Streams, depending on the use case. Okay? For example, Backpressure, what I showed you, Akka Streams has a very good implementation of the Backpressure pattern. So whenever we want to use Backpressure, we use Akka Streams. If the data is too big, then we use Kafka Streams, which is a little bit more scalable and more resilient. You know? So let's go back to the service. Yes, so these are the topics, okay? I have the information there. There's also a very good metrics page here for these topics. If I'm sending and receiving messages, I can see the metrics, and I can see what's going on in there. But I think some maintenance is going on with the service right now, because if I try to see the metrics, it's giving me some strange error. Let's see. Or it doesn't load, but it usually does. Ah, now it's loading, it seems. Yes. Okay, yeah, so I think there was some maintenance going on like half an hour ago, but fortunately we can see it now. That's nice. I didn't think I was going to be able to show you this. So this is the metrics. Yes. Sorry? Kafka is the backbone. Kafka is your messaging infrastructure, you know, and Kafka Connect is an API to access this. Ah, okay. Yeah, within the Oracle Cloud, you can provision. You have the option if you want it to come already with Kafka Connect. If you're going to use Kafka Connect to connect to it, then you provision Kafka Connect as well, and it will create a separate compute node where Kafka Connect lives. Yeah. Yeah, you can decide which size do you want it to be, or you can decide not to have Kafka Connect, and then you will save some money. If you, for example, are connecting from some other type of code or with some other technology, then you don't have Kafka Connect, and your sizing is narrower. Okay. So here we can see statistics. You know, maybe it's still in maintenance because something is not loading. But this here you can see whatever is happening inside your infrastructure. Okay. And I will show you some actual code. For example, it was very quick for me to do this. Yep. This is a demo producer. I just took some code actually from the Oracle documentation, which I'm gonna share with you, and I just had to set these properties. You know, the name of my topic, which I can see in the web page, the IP address that I showed you on the port, and then these properties. I just let them by default. I can change them if I want. Okay, and this, when I run it, it lets me just produce messages to Kafka from a command line. Okay, just very simple. And then I have a consumer, also pure Java code. Okay, I took it from the same place. I need the same topic name, the server information, and then I have here a while loop, infinite while, which starts consuming. This is like a very, not a very good way to work with Kafka, but just for demo purposes, I just want to get all the messages that are flowing through, So I want to know the offset and the value of the value of the message, the content of the message. So if let me show you that. Okay, so for example, I've been producing some messages, demo, Oracle, simple messages. And my consumer, which is running as well, it just receives the same messages, So in this case, I'm just using this like kind of a messaging queue. It's very simplistic use, but just to see that it works. So if you go ahead and provision your Kafka instance, I think everybody gets like these free credits for the Oracle Cloud if you came to the Oracle code. So if you want to go in there and provision your Event Hub Cloud Service instance and just look at the documentation, copy the code, or clone it from the Git repository, then you can do this right out of the gate. It's very quick, it's very easy to do, and you can really see that it's working, that the messages are going through, and you are being able to get the messages even from your own laptop, which is nice. It's not, here I didn't have any problem like security problem connecting to the Oracle Cloud. I mean, you need probably a public key, but that you can download it when you create the service, okay? So as long as you keep that, you're off to the races. You can start working with this very easily, You can connect another application, whatever you want. In Hyderabad, I had a different talk about microservices, and I was using actually Event Hub Cloud Service as my backbone, as my data streaming platform from the microservices, and my microservices were deployed in many different places, and they were publishing and consuming from Event Hub Cloud Service, and I didn't have any problem with that. It was the easiest part, actually. Then I will show you something else. That was just pure Java code. As I said, it's not the best way to consume Kafka, but this is an application created with Akka Streams. Akka Streams is a Scala-based technology from a company named Lightbend. It's reactive, it's used to create reactive applications. So in this Akka Streams demo, what I'm using is the Backpressure capability. So if you see here, what this app does, it starts producing messages to Kafka really fast, a lot of messages using a factorial function. And then it has two consumers, but the consumers, one of them is very slow, and one of them is normal. So if I just let it run as it is, then the first consumer will get the messages. It will suffer a little bit, but it will get all the messages. But the second consumer, which is the slow one, it will fill its buffer, and it will start dropping messages. It will start losing information, So we will have inconsistency there, because one consumer gets everything, and one consumer gets just part of it, So Akka Streams has a built-in capability for backpressure. So all I need to do is, in my code, tell it, okay, my overflow strategy, when the buffer overflows, I'm going to use backpressure, okay? That's it. The rest is just Scala code, which I don't have enough time to explain right now, but I can show you how this runs, actually. Yes. Okay, so I'll just run it. Let's see if it shows. I think it's too big. So it's just producing an amazing quantity of information towards the Kafka platform, And if you see, these two consumers begin running at the same speed and begin receiving all the messages. So what Backpressure does, the applications, or one of the applications, senses that this information is coming too fast for him, So it signals the other application, and it signals the Kafka platform that they need to slow down. So the producer starts slowing down, starts coping with this problem, So then I'm getting same information in both consumers. It's very simple, very easy. In this case, I just have two consumers, but I usually have many consumers, So if one of them is suffering, I need the rest of the system to. I need to be able to orchestrate the rest of the system to cope accordingly, Otherwise, I will just be losing information, and then I can keep running and running and running, and there's no problem even if the messages are big, and I have a lot of speed going on here. So that's Backpressure. I just wanted to show you because it's a different way to interact with Kafka, you know, and this is just connecting to Event Hub Cloud Service using properties and stuff. Okay, so yes, okay, let's go. How much time we have? I think we have like 5 minutes left. So let's go back to the slides. So again, you have Event Hub Cloud Service, very powerful data streaming backbone, very easy to provision. You know, but you have a lot of options to interact with that, to connect with that. Okay, you can, in the Oracle Cloud, you can choose, you know, to have Kafka Connect. You can choose to have the REST API. That's part of the provisioning, and then you can use those tools to connect. If you don't, then you can use whatever else, like I did, Java API, you can use Akka Streams, you can use Kafka Streams. Some other products, if I go into IoT Cloud Service, for example, or I go into Big Data Cloud Service, they are already prepared to send or receive information from Event Hub Cloud Service. So those are just like kind of adapters that you configure, and you start sending and receiving. You know, so that's very easy to do as well. That's the basic architecture. You know, in Kafka terminology, we use sources of data, and sinks. You know, which is where the data is gonna end up. Okay, that's basic terminology. Some interesting use cases within the Oracle Cloud, for example. You know, I've been saying that several of the stuff in there is prepared already to work with Event Hub Cloud Service. For example, Golden Gate integration. If someone here uses Golden Gate, Golden Gate integrates seamlessly now with Event Hub Cloud Service in the links I'm providing in the next slide. Yes, there is even the A-team blog which they created where this integration between Golden Gate and Event Hub Cloud Service is totally detailed, step by step. It works. I tested it. Big data, stream analytics, obviously, we're talking about huge amounts of data, so that's the better fit for a platform like Kafka, Event Hub Cloud Service. Serverless functions, for example, we have the FN project within Oracle. So that's a very common use case now in the different cloud providers, you know. So for example, I know that Microsoft Azure, for example, they have a lot of use cases because they have their own managed Kafka implementation, Event Hub something, and they are using, for example, Azure Functions a lot to take messages and put, especially to consume messages from the data streams, you know. So in Oracle we have the FN project, and that can also let us create some serverless functions that interact with Kafka with very low code, no infrastructure. So that's nice for smaller scenarios. Microservices, of course, are a very good fit together with Kafka. Microservices can be built with Akka, with Wookie, for example, which is an Oracle open source project. That's what I talked about in Hyderabad, how to use Wookie microservices with Kafka. We can use Application Container Cloud. We can use the container native application development platform. IoT, of course, that's another very good use case for using an Event Hub Cloud Service, because with the IoT, we are expecting to receive like huge loads of information, you know, from devices and from a lot of sources, you know. And there we can use, for example, the REST proxy. We can provision the REST proxy because that will let us interact directly with IoT Cloud Service or even with Integration Cloud Service. You know, maybe Integration Cloud Service is not the best fit together with Kafka, but IoT is, you know, because this is like kind of like SOA service bus stuff. So it's not so compatible, but it can work together, you know. So I have put together some resources for you if you are interested in this topic and in this service. Okay, if yeah, I see many people taking photo, but you can also download the presentation just from the Oracle Code agenda. It's already there, and yeah, we have Golden Gate integration. We have the connected car example, which is very nice from Oracle. That it tells the story pretty well about how to use this kind of platform. We have sizing. If anyone is interested in sizing, then you can see a nice resource there. Of course, the administration guide, how to connect ICS and Event Hub Cloud Service through the REST proxy. That's interesting as well. I think this example uses Twitter or something, the Twitter adapter with the ICS to receive a lot of information and send it to Kafka. So I think these resources are interesting. If you go into the Event Hub Cloud Service page, then let me show you. Event Hub dedicated. Let's see if the Wi-Fi is fast or not. Okay, there it goes. Okay, now let's go into. Let's go into my dashboard. This, I think it's too slow. But if you go into your cloud dashboard, if you create your account, go into your cloud dashboard, go into for the first time into Event Hub Cloud Service, then you will immediately have a page with access to tutorials, to videos, and to several resources that let you provision this very quickly. You know that the first time, I have worked with Kafka a little bit before, so I have some experience, but still I use the tutorial just to sort out a couple of things. If I don't know what a specific field means, that tutorial will tell me. So that's no problem. Event Hub dedicated, can go in there. Let's see. Open Service Console. Quick starts. Yeah, for example, we have the quick starts there. You can create some basic configurations right without configuring too much. So yeah, that's basically it. I think we are out of time. But if there are some questions that I can answer right now.
How can you handle inconsistency in partition?
Inconsistency in partition. Yeah, probably you can use some eventual consistency pattern or something in your application code, in your implementation, take care from it. But first you would have to see if that's a problem of the applications producing and consuming to Kafka or of the Kafka implementation itself. If the problem is in the implementation, then you need to tell Oracle to fix it. Yeah. Yes. Thank you.